packet I gave you is all of the notes for the first part of the unit for exponents. Okay, I'll give you the notes for the log portion when we get to that part. But this, I think this takes us through maybe the notes to the end of next week, maybe? Something like that. All right, so we'll just, I think there's what, 6? Maybe it's longer than that. Yeah, because there's 5 different lessons that's clarified on it. Cool? By the way, oh, it would help if I turn the thing on. A ring was found in here, and it was after first period, so anybody lose a ring? Oh, good. You're welcome. Thanks to whoever turned it in. I don't remember because it was like a couple days ago and I forgot to ask. It's been sitting right there. So, see you. Thank you. All righty. So, what do you remember about exponents?
Basically just the number multiplying itself how many times the exponent.
Yep, that's it. That's exactly what it is. It is. So like if you have x to the n, the exponent. Oops, what's today? Ooh, November 1st. The exponent tells you, hi.
It's 2 more.
Yeah. Is that better? I mean, the 2 off? Okay. All right, so as Corey told us, the exponent tells you how many times to multiply the number by itself. Would you agree with that? Okay, and as we remember, looking at a sequence for like the power of 3, how can you rewrite 3 to the negative third so there's not a negative exponent? No. That's a good thought process, though. You remember? How about if we write it as the fraction? And remember, if it's got a negative, we can rewrite it underneath in the denominator. And so, what would 3 to the 1/3 be? What's 3 to the 3rd power?
Oh wait, no. 27.
So that's like saying 1 over 27. And then 3 to the negative 2nd would be like saying 3 to the 9, or 3 squared. What's 3 squared?
Oh wait.
9, so it would be 1 to the 9. And we can rewrite 3 to the negative 1st as 1 over 3 to the 1st, which is just 1/3. Perfect. And we have 3 to the 0. What's that equal? Not 0. 1. Absolutely. Okay, and then 3 to the 1st gives us 3, which if you think about it and think about it as a fraction, it's the flip. 3 squared, 9, which makes 3 cubed, 27. Do we kind of refresh your memory about how our exponents worked? Okay, so that pattern you can do that pattern for any base. When I say the word base, what does it mean in terms of exponents? Well, when I'm talking about an exponent, we have x to the n, correct? That's kind of like a generic way to write an exponent. Agreed? Which one's the base? The x part is, right? That's our base. That's the number that we're multiplying over and over again. And then the n, what's the n called? We call it the exponent, but it's also called what? A power? So what power you're raising that base to? Okay, so they use b here. So we have b to the n, that's how many times, okay? B to the 0 equals 1. Any number raised to the 0 power gives you 1. Do we remember that? Kinda, yes. Callie, did you remember that? All right, awesome. Somebody talk to me. And then b to the negative, and it's going to be rewritten the same way, but as a fraction. Yes? Okay, so if we wanted to write these as repeated multiplication, this is kind of what you did. Hey guys, put your phones away. Kind of what you were doing last night to figure out what the answer was raised to. So just to rewrite 3 to the 4th, oops. That would be like rewriting 3 times 3 times 3 times 3. Anybody remember what 3 to the 4th power is? 81? Do you just know that one? Yeah, because it's easier. You can do 3 times 3 gives me 9. This 3 times 3 gives me 9. Now I know 9 times 9 will give me 81. What about 2 to the 5th? That was on your list last night. Anybody remember what 2 to the 5th off the top of your head was? Let's prove it's 32. So I have 2 times 2 times 2 times 2 times 2. All right, 2 times 2 is 4. These 2 times 2 is 4. And then I can say, hey, 4 times 4 is 16 times 2. And that gives me 32. Is that what you guys did to figure out your powers chart last night? How did you guys do it? I mean, there's multiple ways, but give me one example of how you did it. Anybody? Maya, how did you do your power chart last night? So you just, was it kind of like this, or did you just go 2 times 2 is 4 times 2 is 8 times 2? Did it straight across? Okay, and that works too. All right, how can I rewrite 4 to the negative second without a negative exponent? Hey, Miss Emma, how can I rewrite that as a multiplication without a negative exponent? Yep. So it would be 1/4 times 1/4, which is going to give me 1/16. All right. sometimes we have functions with exponents. Exponents are a function, and so we have to evaluate them, just like we evaluate on the other ones, or any other normal one. What color? Alex, pick a color. I already used purple. Orange, okay. All right, so when we're doing that, we're going to do it just like we did any of the other ones, all right? So this is like saying I replaced x with 2, and so if this is my function, that's like saying f of 2 is equal to 2 squared. And I know that 2 squared is what? Everybody should know this one. 4. Yeah. And so if I have f of 0, that's like saying 2 to the 0 power. What's any number raised to the 0 power? 1. All right, and last but not least, if I have f to the negative 2, that's like saying 2 to the negative square, which would be like saying 1 over 2 square, which gives me 1/4. Remembering this, coming back in your memory banks? All right, couple quick review of the property, exponents and properties or laws or whatever you want to call it, okay? Jeremy, pick a color.
Green.
All right. Okay, so one of the biggest ones is when we want to multiply like 2 cubed times 2 to the 4th, okay? If we wrote that out, it would be like saying 2 times 2 times 2, agreed? And then we would be saying times 1, 2, 3, 4. Do you agree with that? Okay, so I could sit there and calculate out, let's see, well that's 4, that's 4, that's 4, and that one just kind of comes along for a ride. And that's 16, that one's 8, and that's going to give me 128. Now, what do you notice? How many 2's did I write out? 7. So what do you notice about my original problem? Say that again? Yeah, because I did basically 2 to the 3 plus 4, which gives me 2 to the 7. Okay? So if I followed that same rule, how could I rewrite this problem? It would be 2. I would add my exponents, and that gives me 2 to the 8th. Who remembers what 2 to the 8th is? Anybody? Yep, sure would. All right, so, excuse me. My last one. If I have 2 to the m times 2 to the nth, how am I going to rewrite that to show it as a product?
2 to the m positive.
Yep. And that's just my answer then. Good so far? All right, then. Callie, pick a color. Fuchsia? Is that what that's called? Magenta. Okay, I like that one better. Okay, so. Okay, we're good with our rule, right? What's our rule going to be? If I wanted to, in fact, looking at this example up here, what's the rule? What did we do to the exponents? Do what? Yeah, we added them. So the rule is, if the base is the same and multiplying of the exponents okay. So, but what happens if I have a negative exponent? Does that change anything? What do you think? Well, let's rewrite it as a single, okay? If I have 2 to the third times 2 negative first, is my base the same? I both have 2, so my base is the same. If I rewrite it, it would be 3 plus a negative 1. Would you agree with that? Following my rule. And that just is going to give me 3 squared. Okay? What's 2 squared? That equals 4, right? Okay, let's multiply it out and see if that rule works. So 2, my 2 cubed, 2 times 2 times 2. All right? And I'm multiplying that by 2 to the negative first, which is really like saying 1/2. Would you agree with that? All right, let's multiply them out. What's 2 times 2? 4 times 2 gives me 8. 8 times 1/2 gives me 4. Okay? So, doesn't matter if you have a negative exponent or not. The rule stays the same. Okay? Good so far? All right, one more rule that we got to do. Okay, so let's look at, see if the light purple will work out. Let's expand this out, okay? This is, remember with parentheses, got to start on the inside. So this would be like saying 3 times 3. Would you agree with that? And that would be cubed. Okay? Now, what's 3 times 3? 9. And then what's 9 cubed? What is it?
729.
All right. Okay, so let's think about this. If I had said, how many 3's to get to 729? 3 times 3, that gives me 9, right? Okay, 9 times 3, so I'm up to 3 now. That gives me 27. Do you agree with that? Okay, so I got 1, 2, 3. Now I'm multiplying it by the 4th. What's 27 times 3? 81. Okay, multiplying by 3, that gives me, I'm up to 5 3's now. What's 81 times 3 get me? I'm going to go back up here. 243. What's 243 times 3? 729. How many 3's did I use? 1, 2, 3, 4, 5, 6. What pattern do you see? Huh? Yeah, multiply. If it's a power to a power, you could rewrite this as saying 3 times 2 times 3, which gives you 3 to the 6. Okay? So, for the next one, that's like saying 4 times 2, which is going to give me 3 to the 8th. What's 3 to the 8th? Anybody know? Uh-huh. 6,561. Whew, that's a big one. Okay, so again, I can just rewrite this as 3 to the m times n. Okay, so my rule, if it's a power to a power, okay, which basically means 1 base, 2 exponents. Okay? You multiply the exponents. Okay? And it works whether you just, with your negatives, you just got to follow the negatives rule. So like this would be 3 to the negative 2 times 4, which is going to give me 3 to the negative 8. Okay? Good? All right, quick homework tonight. Okay, you're going to have a quick recall. These are following the rules, but please note on the directions that when I give them to you, you do not need to give the exact answer. Just rewrite them showing the steps. And then under this three sections, rewrite the properties and the rules in your own words to help you remember what they are. Okay? Good?